Yes, I can see this.
Okay, good.
Okay, so this is also delta math. I have another students also use this website. Okay, so they give you this function. Now let me ask the load annotate here. So they give you this function, right? Then that's you find dy over dx in terms of x and y. So this one, first, you can derivative both sides, but you need to consider here y that's a function, x is it's a variable. So both sides derivative, you can get the left side, a constant when you derivative, you got a 0. So this first term, that's 0. Second term, this one will equal 6x squared, right? Then plus 4. This one that's you need times dx. This for the left side. The right side, that's a y cubed derivative. You got the 3 times y squared, right? Then minus 2 times y. Then this one you need times dy. Did you understand this? Zach? Hello?
Can you hear me?
Yeah. My question is, do you understand what I write here? Do you understand? Oh, you cannot hear me? What? You cannot hear what I... Okay, now let's see. Can you hear me? Okay. Zach? Zach? Okay.
Okay, I can hear you now.
Yeah, can you hear me now?
Yes, sir.
Okay, great. Now share your screen.
Yeah. Sorry, I don't know what happened.
Oh yeah. Let me get. Oh yeah, good. So now let's see. To calculate dy over dx, you need the derivative both sides. So here, you need to just do this way. Okay, now let me write here. This derivative left side about x. So constant derivative, you got a 0. Then 2x power 3 derivative, you got a 6x squared. This is a polynomial function, right? Then plus 4x derivative, you got a 4. So then this princess, you need a time dx. This is the left side. Then you derivative the right side about y. You got this also the polynomial function. You got a 3y squared minus 2 times y. Then this one times dy. Okay, my question is, do you understand what I write here?
Yeah, so whenever you take the derivative, it's
Yeah, take the derivative of both sides.
yeah.
The left side only related to x, so we take the derivative about x. The right side only related to y, so we take a derivative about y. Then they ask you dy over dx. So then we both sides divide by dx. Say both sides divided by dx, right? So then say left side dx divided by dx, this one comes out. So we got 6x squared plus 4 equals 3y squared minus 2y times dy over dx. Then you do both sides divided by 3y squared minus 2y. Again, both sides divided by this. Then you get dy over dx, that will equals this. So this one comes out. So then later, finally, we got a dy over dx equals 6x squared plus 4, then divided by 3y squared minus 2y. Okay, so this is a final answer. Do you understand?
I think so. I think so.
Okay,
Yeah.
so then you can put this answer here, check if it's correct.
Yeah.
You need to add the parentheses, right? Then divided by 3y squared minus 2y. Yes.
Okay.
Good, good. Now let's see.
All right. Something like this one.
Yeah, this one, the same thing. Now, but here, you already have the x and y mixed up on the left side. Right side is 0, right? So this one, you need to use product rule, for this term. This one, first let's do derivative about constant equal to 0. Then this term, first, you need a derivative about x. This is because this one is x times y. X derivative about x, you got the 1, right? Then that will be times y. Because derivative of x, that's 1. Then times that equals y, right? Then here you can write this one x, then times derivative of y. So this one will equals let's say this one will equals dy over dx. Okay. This one, let's say actually when we derivative this first term, this is x, then that's 1, they need times dx. Here needed times dx. Okay, now let me write clearly. Then let's see. Okay, so this one, that's this first term constant, you derivative equal to 0. Second term, you can write x derivative about x, you got the 1, then either that's times dx. So that's dx, we can write this dx times y. This is the first term. Then plus x times dy. Then this is a product rule. We got the derivative of this term. Now this term we got say 12. This is a polynomial function. So this one equals 3y squared, then dy. So 12y squared, then dy. Okay, this one equals 0. Now, you need to solve dy over dx. So now to do that, let's first merge the term with dy. Then expand this one, we get a 3y times dx. This is the first term, right? 3 times y times dx. Then plus 3x times dy. Then plus 12y squared times dy. This one equals 0, right? So the term with dy, that's this one and this one. So we need to take the common denominator dy out. So this two term without change to dy, then parentheses 3x plus 12y squared. Then this one equals 0, right? Now the first term is this, second term is this. So to solve dy over dx, we can do both sides minus this term. So then I can write here, that will be dy times 3x plus 12y squared. This one equals negative 3y dx, right? Because at the beginning, they're both on the left side. Then we try to solve dy over dx. Now both sides next minus this term, minus 3y dx. So left side, this term will go. They'll go to the right side. That will be a negative. Now both sides divided by dx. Divided by dx. Both sides divided by dx. So right side, dx divided by dx, gone. So now we try to find dy over dx. So now both sides divided by 3x plus 12y squared. Okay, both sides divided by this, 3x plus 12y squared. Then you can see the left side, this one gone. The right side, what do we get? That's negative 3y divided by 3x plus 12y squared. But then we can see I have a common factor 3 here. We need to simplify. This one will be negative y over x plus 4y squared, right? This one's the answer. Now, do you understand? Do you have any question about this?
Yes, where is it?
Okay, you can see step by step. This one, first one, do you understand?
Yes, I understand.
Okay, then expand it right to this. I just distribute this 3 to these 2 terms.
Yes, I understand. I don't understand going from the third step to the fourth step.
Okay, so from here, these 2 terms, we have a common factor dy, right? I just take this dy out. Then I have, in the parentheses, I have 3x plus 12y squared left, right? So then you can see the left side, that's 3y times dx, then plus dy times 3x plus 12y squared. This one equals 0, right? So now I'm trying to find the dy over dx. Actually, if you don't move to the right side, that's also okay. Say, first both sides divided by dx.
Yeah.
Then this one comes out.
I get it now.
Yeah. Then both sides minus 3y. Then go to the left side. That's this one will gone. Right side, you have negative 3y. Then you divided 3x plus 12y squared both sides. Then you get this one. That's dy over dx equals negative y over x plus 4y squared. Okay, so then you can input your answer here. Let me take this one away. Then you can see that's clearly. Yes.
Okay.
Good, good.
All right. And then something like this one. This is the last one.
Yeah, this one asks you the second derivative. Second derivative, same way. After you got the first derivative, then you do one more time. Okay, now let's first find the first derivative. Let's first find the dy over dx. Okay, you need to find this one first. If you did not get this one, you cannot get the second derivative. Say this one, the exact same rule. You know, the constant, when you take derivative, you got a 0. So left side, this is a 0. Right side, first, you derivative about x. X derivative about x, you get a 1, right? But you need times delta x, dx, times dx. Dx then times y. Because this is a product. First, you derivative this one regard to x. Then the y keeps the not change. Then you plus second term that's related to y. You derivative about the y, then keep x stay there. So x times y derivative about y, that's 1. Then you need times dy. So this one, after you derivative about x and y, you get this. Then now this term, you only can derivative about y. If you derivative about x, then you get a 0, right? So then this one give you minus dy. Okay, so then you need to simplify, you merge the like terms. So these two terms with dy, we need to merge these two terms together. We can write this one, that's 0 equals y times dx plus x minus 1, then times dy. So then we are trying to find dy over dx. So that means we need both sides divided by dx. Both sides divided by dx. So this term will become y. So then we both sides minus y. We got a negative y equals x minus 1 parentheses times dy over dx, right? So then to find the dy over dx, you need to divide the x minus 1 both sides. So you divide the x minus 1 both sides. So now we get the first derivative. Do you have any questions for this process?
No.
If no, that's very good. Now you already have the first derivative, that's negative y over x minus 1. Okay, from this, we try to find the second derivative. You just do the second derivative of this one. This is the division. So negative just keep there. Then derivative of this function, y derivative about, you know, this is a derivative about this one. You got the 1, right? Y derivative about y, you get the 1, right? The 1 that actually that will be the y derivative. This one then times x minus 1. This is a derivative of the numerator times denominator, then minus keeps the numerator there, then derivative of the denominator. That will give you the x minus 1 derivative, you get a 1. Then over this one square, x minus 1, this one square. Now let's simplify this. So what is it? Now let's, we need to simplify this. Okay. Here, because the y, it's this one is not the variable, it's a function. So that's the reason when we derivative about y, we still here write y derivative. So then this one give us negative, say this is a negative. Then this negative would distribute, also need to distribute to each term up here. So now let's switch this order, then make that, we don't need this negative here. That would be y derivative times x minus 1. Then divided by x minus 1, this one square. Okay, you know this one actually equals y derivative. dy over dx, that's actually y derivative. That means y derivative equals this. That means we need to use this one to replace this y derivative. So we can continue simplify. This is a y minus, so this one also minus, that would be plus. This one changed to plus, y over x minus 1 times x minus 1, then divided by x minus 1 parentheses square. So say x minus 1 cancels out with this one, 1y plus y, 2y over x minus 1, then parentheses square. So I think the answer for this one equals this. Now, do you have any questions?
Yes, the going from the y minus y prime x minus 1 to the next step.
You can use your mouth pout input. Oh. Yeah.
These two, from this one to this one.
Yeah. If this one is correct, now y derivative, say dy dx, actually that's y derivative. That's one equals this. So we need to replace this y derivative. This is a y derivative. Use. Yeah, okay. Negative y over x minus 1. Because this is minus, this also has a negative. So I change to plus. Say, because y derivative equals negative y over x minus 1. We also has negative here. So negative times negative, I change to positive. So y over x minus 1 times x minus 1.
Okay.
Yeah, then you can try input that enter there, see if we did it correct. Oh, wait. See this one that at the point 2 minus 2 and negative 3 in the simplest form. So that means let's wait. Say here, looks they're looking for the number.
Oh, okay.
So they give you this point. So that means we need to plug this number here. Now let's see. When x equals 2, that's x minus 1, that's 1. Then y equals negative 3. This is negative 6 over 1. So this one equals negative 6. So this one, I think the answer equals negative 6. Yeah. Is that correct?
Okay, yeah, that's right. Okay.
Yeah, exactly.
Okay.
Very good.
And then, let's see, I think it was this one.
Okay.
Yeah, inverse function, something like this.
Okay, so the function f is defined by this, right? They give you f0 equals negative 6. Yes, if g is the inverse function of f, what is the value of this one? Okay, so now let's see. First, we can find the derivative of this function. Then you can get derivative of fx. This one equals 3x squared plus 4. Right? This is the derivative of this one. Mm-hmm. Then they give you g, it's inverse of this function. Oh, that's this one. It's say when if g is the inverse of this one, we can get g negative 6 will equal 0. This one will equal 0. But then they are looking for g derivative of this negative 6 equals what? Right? From here, we can get this. Now, let's see. Derivative of this. Say this original function is this derivative of inverse function. Now let me see. This one should should have a formula. That should be 1 over that. Give me a second. Now inverse. Let's see, this fx equals this. Then we can get the g that's inverse function of f. Then inverse derivative relation. Okay, that will equals. Yeah, exactly. You know, they have a formula. This one, it's gx derivative. This one equals 1 over the original function derivative at gx. Okay, so then you can see here we are trying to find g derivative negative 6. So this one equals 1 over this function derivative. What do we get is this, right? Then you prog the gx x equals negative 3. When the x equals negative 3, the fx that's equals 0. We have this relationship. So you get this one that's 0. You prog the 0 to this one, you get the 1 over 4. Now, did you get it? The answer is 1 over 4.
Okay.
Yeah, you can try it first. Now let me explain to you.
Okay.
The answer is correct, right? So the reason, you know, you need to understand you have this formula. When you try to find the derived function, suppose g is derivative of it's an inverse function of fx. Gx is the inverse function of fx. Then derivative of gx will equals 1 over derivative original function. Then here that's gx. You need to know this formula. Otherwise, you don't know how to do it. If you know this formula, this will be very easy. Say we are looking for g derivative, this one's negative 6, right? So then you just prog this g, that's negative 6. Then g negative 6, based on the inverse function, this one should equal 0, because we can find it from here. f0 equals negative 6. So gx is reverse function. It's an inverse function of fx. So that means g negative 6 equals 0. this one equals 0, then we already got the derivative of fx that's equals 3x squared plus 4. Then you just plug x equals 0 here. Then you get this one equals 4. But that's one is on the denominator position, right? So then you get that one will equals 1 over 4.
Okay.
Okay, now let's go to the next one.
All right.
So here they give you this fx. Then they also give you this. They ask that -1, that's a inverse function of f. Then they ask you this one in -5. This one exact same with the previous problem. So first, now let's find the derivative of fx. This one equals -3x squared minus 2, right? Then from this, you can get the inverse function. This one, -5, will equal 0. Then the inverse function of f, this one derivative, -5, based on that formula will equals 1 over f derivative, then f negative this -5. So then you can plug this one here because this one equals 0. So that means you need to get this, put this one 0 square minus 2. So the answer for this one equals -1 over 2. The answer is -1 over 2.
I think I understand that.
-1 over 2.
Yeah. Okay.
Now you understand?
Yes, sir.
Okay, good.
And then the next one. Trig function, something like this.
Okay. This one, they ask you give this answer. This one it's equals derivative. Actually, here they use the difference to approximate the derivative of this function, right? Then when h go to 0, this will give you exactly the derivative of arcsine. Now, do you remember the formula for arcsine? Arcsine function derivative that should be equals 1 over 1 minus x squared square root. Now let me double check, okay?
Okay.
So this one, yes, that's exactly. Let me see. Arcsine, yes, exactly. This one, the answer is 1 over 1 minus x squared, then square root. Yeah, input the answer there. Derivative of this one, this actually asks you the derivative of arcsine x. They ask you find this. This one equals this. Zach, are you there?
Yeah, I'm here. Sorry, I just don't know. I gotta understand. Is it so? Is arcsine equivalent to the one over?
Yeah, 1 over square root of 1 minus x squared. So this one's 1 over 1 minus x squared, then square root.
Mm-hmm.
This is a very basic derivative of inverse trig function.
Mm-hmm. Okay.
Yeah, see, that's correct.
Mm-hmm. And then this.
Okay, so given this graph and y equals fx and y equals gx, show that h equals fgx determine the, okay, they give you y equals fx, y equals gx, and show that hx equals f, and h has gx. Then determine the value h derivative 2. Okay. Now let's do this. This one, this is graph of f, right? This is graph of f. Then this is a graph of g. Now they ask you to find the derivative of h2. So first you need to find the this one, because this h equals this. So based on the chain rule, derivative of hx, this one equals derivative of fx, then times derivative of gx. This one equals this. So first you need to find that. So now it's x equals 2, right? So in the x equals 2, this one, first you need to find the derivative of this one, g2. Then the times the derivative of this one when x equals 2. So first, the derivative of gx when the x equals 2, find that one.
Mm-hmm.
Now let's go, can you move the up? Yeah, okay. So when the x equals 2, x equals 2 is this part, right? Mm-hmm. So first, this part is a linear function. So derivative of this one, just the slope of this line. So you need to find the slope of this line. Can you find the slope of this line here?
Oh,
so
yeah,
now,
yeah.
So what is the slope of this? 1, 2, 3. This 1, 2, 3. This is a -1. Slope is -1, right? So when x increase, y decrease. So then that means this slope is negative. So say when x increase 3, this y value decrease 3. So that's delta y divided by delta x. So that would be decrease -3 divided by 3. You get this one equals -1. So that means this one equals -1. Derivative of g2, this one equals -1. Now we need to find the derivative of fx. So when x equals 2, what is g2? When x equals 2, g2 equals 6, right? You can read here. When x equals 2, g2 equals 6. 6, then that means in the graph of x, you need to find x equals 6. When x equals 6, here, right? When x equals here, that's here. Then this fx is also a linear function. So derivative of this function, it's also that means slope of this function. So then can you find the slope of fx at this segment? So
Yeah.
you can read this one. 1, 2, 3, 4, 5, 6. X reads the 6. Y reads 1, 2, 3, 4. So the slope is 4/6. That's equals 2/3. Mm-hmm. Right? So that means this part equals 2/3. 2/3 times this -1, they will give you the h derivative of 2. So that's equals -2/3. This one is answer. Now do you understand?
Yes.
Any question? No, now let me explain one more time. You know, here, what do we use that's called chain rule. This one called chain rule. Chain. Okay? Chain rule. The reason we use this chain rule because this hx is a combined function of f and g. Okay? So when you try to find the derivative of h, first you need a derivative of f. But f is the variable in fx, that's a gx. That's a media. It's another function. It's not the final variable. So that's the reason we need to keep derivative of gx. Then say first you derivative of fx. Then because the fx variable is not the final variable x, it's a gx. So then we need to use chain rule, keep derivative of gx. Then gx is the variable that's a final variable x. So then we are stopped here. If gx is still another function of x, then we need to keep use the chain rule until we reach the final variable x. Then we can stop. Otherwise, we still need to keep doing this. Then when you try to find the value for this, then you need to go backwards. First, because the variable of gx, that's 2, that's x equals 2, you need to find the graph on gx when x equals 2. What is that function in that part? Say, when we find x equals 2 on the graph of g, this is a linear function. That's a line. Then you derivative of this line, that's just to find the slope of this line. Slope of this line, say when x increase 4, y decrease 3. So that means the slope of this line equals, when x increase 3, y decrease 3, the slope is -1. So that means the derivative of g function at x equals 2 equals -1. Then we go backwards to fx. So then say when x equals 2, g2, that's equals 6. This one will give you the variable in fx when x equals 2. What is the gx? Because variable in fx, that's gx, is not x. So then you need to find what is gx, what is g2? When x equals 2, g2 equals 6. So that means the variable here, that's 6. So then you need to find the x equals 6 on the graph of fx. This one gives you the function here. That's also a linear function. So that means we need to find the slope of this line. This line, you know, because x increase 1, 2, 3, 4, 5, 6. X increase 6, y increase 1, 2, 3, 4. So that's delta y over delta x, that's 4 over 6. So we get the slope of this line equals 2/3. So then this gives us the derivative of fx at x equals 6 on the graph of fx. So that's 2/3 times -1, then give us the derivative of h2. So that's equals -2/3.
Okay. Yes, sir.
Yeah, then you can try this answer.
Okay.
-2/3.
Yeah. Okay.
Say correct, right? Now let's say from derivative of this one. Derivative of this one, first, you need to say what is this function is. You can first say, use a chain rule, right? This one function is e power like gx, okay? Then here you set gx equals 7 times x power 6. So first you write the y equals this. Then this function is a exponential function, right? So the derivative for this one equals this function, because this one is not e, right? So that's 7gx, then times log 7, right? Log 7, because this one is not e. If it's e, then remember e power x, you derivative this one, you just get this one, it is solved, right? But a power x, you need to use this formula, derivative this one give you a power x, then times log a, times ln a, okay? So say here, this one is exact same like this, but only one difference is here, this x is the final variable, but here gx is the mediate variable, it's a middle variable, it's not the final variable. So that means we still need to use chain rule. So this is the derivative of the 7gx, but gx also needs derivative. We need to continue times this. Then you can just find the derivative of this one, derivative of gx equals what? This is a polynomial function. This one very easy. Just use 7 times 6, 42, then times x power 5. Because in this function, the final variable just x, so we are stopped here. So then you just plug this one to here, simplify. So gx just write this one 7 x power 6, then times log 7, then times 72 x power 5. Then finally, you can take this, all the coefficients in the front. You got a 42 times log 7, then times x power 5, then times 7 power 7x power 6. This one is the answer. You can, do you have any question about this? So here, they ask you practice for the chain rule. See, to do this, we first write gx equals 7x power 6. Then we can write this function like this, right? Then we can use this formula, a power x derivative, this one equals a power x times log a. That's what I write here. If this is x, then you're done. But this one is not x. This one is a middle variable. Gx is still dependent on, is still a function of x. So that means we need to use chain rule. Keep find the derivative of gx. Gx, you know, this one is a polynomial function, very easy. Derivative of this one just equals 42 times x power 5. Then you times that one here, then simplify, then you got this one.
Yes, sir.
Yeah, you can input the answer here.
But the bit that I understand is this, the log 7.
Yeah, log, ln 7. You can input here, 42 times ln 7, ln 7. You can add parentheses around this 7, around the 7.
7.
No. Add here around this 7. Yeah, make that.
No.
Yeah, okay. Then let me take this away. Then, yeah, add here. This one you don't need to add the parentheses around the x power 5. You don't need that parentheses.
Mm-hmm.
You don't need that. Yeah, this one that's fine. Then 7 power not equal.
Yeah, no, I know it was my bad. I was just pressing backspace.
Yeah, power. Then 7 times x power 6. Yeah, this one should be right. See,
Okay.
correct, right?
Yeah.
They give exactly. You need to add parentheses 7 around 7. Otherwise, that will confuse.
Mm-hmm.
Okay. Good. Now let's see this one. This one says ask you use this chart to find the derivative of hx at x equals 2. Okay. Say based on this function, hx equals this, right? So that means h derivative of x equals fx derivative minus gx derivative. Then if you found this one too, just find the derivative of f2, then minus derivative of g2. Okay, so here, when x equals 2, they give you derivative of fx equals 6, right? So that means this term equals 6. Then you need to get the g2, g derivative 2, when x equals 2, g derivative, this one equals -7. So that's minus -7. So what answer you got here?
13.
Positive 13. Yeah, you're right.
Yeah. Okay.
Good.
I think that's it. Honestly.
Yeah. Now let's see this one. They give you this one. Now they find the derivative. This one, both side derivative. Sine derivative, you got the cosine x, right? Then this one is still not the final variable. So then you need to use chain rule. So first keep this one here. Derivative of this one equals sine derivative equals cosine. Then use chain rule to find this one. They got a product rule, 2x times dx, then times y squared. This is the first term. Then plus this will be x squared times 2y, then dy, right? This one will equals 3 times dy. Okay, so we got this. Then they ask you find the dy over dx. So first, we need to distribute this cosine x squared y squared. Then you need to find the like terms related dy put together. So first, distribute this one to inside our parentheses. So the first term down, let me write, this will be 2x times y squared, then times cosine x squared y squared, then this one times dx. Okay, this is a term related to dx. Now continue times this one with this. You got the 2x squared times y, then times cosine x squared y squared, then this one dy. Okay, then this one will equals 3 times dy. So say we need to put the dy term together. We need to merge this one with this. So the easier way to minus 3 dy both sides. Then we can get this term will be 2x squared y cosine x squared y squared, this one minus 3. Then take this one out, then times dy. This is a left side, but we still have this one on the left side, right? So then you can both sides divide dx. This one divided by dx. So this dx cancel with this one. So you got this one plus this one equals 0. So to get this one, we need to move this one to the right side. Now let's do it right here. You get a 2x squared y times cosine x squared y squared minus 3. Then parentheses dy over dx. When you both side minus this term, this one will gone from the left side. They will go to the right side, but they change to the sign to negative. Negative 2x times y squared, then times cosine. This one will be x squared y squared. Okay, then you need to use the parentheses. Okay, then both sides divide this one, this term, divide this. Both sides divide this. Then you get say cosine this one x squared y squared minus 3. This side also 2x squared y cosine x squared y squared minus 3. See, the left side, this one cancels out. The final answer now, let me write here clearly. That will be negative 2x y squared cosine x squared y squared. Then divided by 2x y, oh, this one minus 3, okay? 2x squared y times cosine, then this x squared y squared, then minus 3, okay? This one's the answer.
Okay.
Now, let me take this. Do you have any question?
Yes, just where does cosine come from?
Yeah. See, when you take the derivative, here you need to use chain rule because the left side, this is a sine function, right? Both sides take the derivative. Sine take derivative because, do you know this formula? Sine x derivative, you got a cosine x. This one, if you derivative this one, you got a cosine x. Do you know this?
Okay. Yeah, I know.
Yeah, that's the reason. You know, you consider this one is it's a complex function. When you derivative this one, first let's derivative sine x. You got a cosine x. But this one is not x. It's still a function of x. So then we need to keep here, then keep derivative of this part. This part, you know, it's a product. We need to use product rule. First, derivative about x, you get a 2x times dx. Then y squared keep there. Then second term, so x squared keep there, then derivative about y squared, you get a 2y times dy.
Yes, sir. I understand.
Yeah, okay, good.
Okay.
Now let me take this part away, then you can input your answer.
Yeah.
After you input, don't submit yet. Now let me check what your input is correct. Which high school you're attending?
Fulshire High School.
Fulshire High School. Oh, Fulshire. Oh, it's a very good school, right? Private school, right?
No, sir. It's public.
Public school. Which part of Houston?
It's in Fulshire. It's just west of Katy.
Oh, west of Katy. Okay, got it.
Yes, sir.
Okay. Minus 3. Okay, that's exactly right. Okay.
Yeah. Okay.
Good.
I understand it. Yeah.
Okay. So now, do you have other questions?
No, sir. That's all the questions that I have.
Okay. Good. If you have other questions, just contact me. You know, this one I taught the calculus in college more than 10 years, and I tutor a lot of students So a lot of college students. So I'm really familiar with this one. So just connect me. Okay.
Yes, sir. Thank you.
See you. Bye.
Okay. See you. Bye.